Okay, part 2 of this lesson. So we're actually going to zoom ahead, I think a page or two. So find your way to this one. So it's number 3. Oh, I got to flip my laptop. Hopefully it doesn't fight about this. Okay, so go away. So it says complete a table of values from -3, x equals -3 to x equals +1 for this equation. So this equation, again, if I tried to factor it, boop, 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 so two numbers that multiply to -4 and add to +1, it is not factorable, not easily factored. So what we can do is create a table of values. What that is we're going to say what's an x value and the corresponding y value. So we're going to do -3, -2, -1, 0, and 1. And just look for the corresponding y value for that. So again, what we're going to do is substitute in x equals -3 into that. So y equals -3 squared plus -3 minus 4. It's -3 squared. Put brackets in it if you need to in your calculator. That's +9. So 9 minus 3 minus 4 is 2. Now we're going to do the same thing with x equals -2. So -2 squared plus -2 minus 4. So -2 squared is +4 minus 2 minus 4 is going to be -2. You can pause it now and fill in the rest of those, but again, substituting in x equals -1, x equals 0, x equals +1. And what you're going to get is a nice little table of values that looks like this. We have some extra stuff. So -4, -4, and -2 are the remaining ones there. Sorry. You might have written this and you might be mad that I'm now erasing it, but I was just showing you kind of what to do. So we could then plot all of those points on this nice grid that's already made for us. So x equals -3, y equals 2. So that's going to be a point. A point that's right there, blue. So, nope, things are not going well. So -3, +2. -2, -2. -1, -4. 0, -4. And +1, -2. So this is what we can see so far of the graph. So let's summarize the characteristics. You can see we have the same function summary as we had before. Sorry, that's not in the right spot. We have that same function summary. So again, your y-intercept is equal to the c value. So our c value is -4. So our y-intercept is at 0, -4. We actually already plotted that on with this piece of information. When x is equal to 0, y is equal to -4. The direction of opening, if we hadn't plotted this out, we would be able to figure it out because our a value is positive, so it's going to open upwards because a again is greater than 0. Our axis of symmetry, so this one's a little bit different in that we don't have any x-intercepts right now. So we don't have any lines along or any points along that line right now. It does exist, but we just don't have it. So our axis of symmetry is again halfway between 2 points with the same y value. So we could do these 2 points, or or if we felt like it, we could do these 2 points. It's actually going to get us the same value. So let's just choose the one that I did with my green here. So halfway between those points. So again, what you're going to do is take your x values, -1 plus 0, and divide it by 2. Add those two values, x values together, divide it by 2. So my axis of symmetry is along the line x equals -1/2. So that's where the axis of symmetry is. If I did it with the purple line, just to prove to you that I'm not lying to you guys 100% of the time, so adding our two purple values, so -2 plus 1 divided by 2. So -2 plus 1 is -1, divided by 2 is -1/2. So as long as I choose two values that have the same y value, we will end up with the same value there. So our axis of symmetry is along the line x equals -1/2, -0.5, same. Again, it's the same as we had in the last lesson. It seems to be lots of them are opening upwards. So it has a minimum value. So the minimum or the vertex will be on the axis of symmetry. So we're going to sub in x equals -1/2 to the original equation, x squared plus x minus 4 equals y. I put it on the wrong side. So -1/2 squared plus -1/2 minus 4 equals y. So -1/2 squared is +1/4. So negative times negative is a positive. Minus 1/2 minus 4. So 1/4 minus 1/2 is -1/4. Minus 4 is -4.25. Right? Right. Yeah, I got it. Oops, not that one. So our minimum value is at x equals -0.5, and the y value is -4.25. So this one's a little harder to kind of draw onto our graph. So we know it's going to be on that axis of symmetry, and it's, you know, not quite halfway between -4 and -5. And then what you can do is connect your little happy parabola. Whee! Oops, kind of missed that one. But it's going to look something like that. Our last part of our function summary is our domain and range. We know that it's just going to keep stretching farther and farther to the left and the right along your x-axis. Our range has some restrictions because it has a minimum value. So that means we need to have y is greater than or equal to -4.25. So y values are all above that minimum of 4.25. So I think that's it for that one. So a table of values helped us out, right? We couldn't factor it the way we could with the previous questions from the last lesson, so it wasn't easily factorable at this point. So we needed to create a table of values, and from there we got some information. And so again, if you need neater writing, there we go. So I'm going to go back now. So this one actually gives us a partial table of values. So it's a partial table of values for the function. You see this is looking a little bit weird. It's still a quadratic function because it has x to the power of 2, but we've got like weird decimals, and you can see all of our table of values is looking pretty gross. But that's okay. It still works exactly the same. If this is stressing you out, change it to y. And so what we can do, so use the information in the table of values to sketch a graph. So you can just plot your points along here. So your x-axis is along here, the y-axis is up, So we have a point at 0, comma 0. We have a point at x equals 1, y equals 2.88. That's pretty good. We have a point at x equals 2, y equals 5.52. Oh. And then it kind of gives us a void in the middle, but we have x equals 12, y equals 18.72. Uh-oh, sorry, I was trying to drag my finger so that I could see where 12 was. I messed up everything. So 12 goes up there, 18.72 is like right here. Hopefully I got that right. And then at 13 is also at 18.72. And that's really all we have. So just to kind of sketch it in there, we know what it's going to look like. It's going to be a quadratic function. It's going to look way nicer than that in real life. That looks like some sort of like scary monster that is chasing you. But it should be a nice little quadratic, and it should look a lot better than it does on here. Let's see if it looks better in this. Probably not. Go away. Not much better. It still kind of looks like a weird. Oh, that's a really weird shape. That's terrible. But that's kind of the graph that I drew on that one. So it says use the table of values to sketch a graph to determine the axis of symmetry, determine the maximum or minimum values of the function. So lots of pieces that we could actually pull out of this. So in this case, our y-intercept, we're given when x is equal to 0, y is equal to 0. So our y-intercept, where it crosses our y-axis, is this guy right here. We could also figure that out from the equation, because right now it's y equals 0.12x squared plus 3x. So our c value is actually equal to 0, because it doesn't show us anything, so it's plus 0. Because remember that our c value is our y-intercept. So plus 0 is the c value, so our y-intercept is at 0, 0. But again, we're also given that in our table of values. It's going to open. You can see just from how it looks, it's going to open down. But that also comes from this negative in front of our coefficient in front of x squared. So our negative a value means since a is less than or equal, no, just less than 0, it's going to open down. Our axis of symmetry is going to be halfway between 2 points with the same y value, or along the same y value. So where that's actually going to come from in this one is it's going to come from this portion. They have the same y value of 18.72. You can also probably just tell that by looking that it's going to be between that 12 and that 13. So if you care to humor me. So 12 plus 13 divided by 2. So 12 plus 13 is 25 divided by 2 is 12.5. Yes, you already knew that because you're a smarty pants. So our axis of symmetry is not easily drawn on this. Oh, that was going good to start. Boop, 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 whatever. It's along that line. Is along the line x equals 12.5. It has a maximum value because again it's opening downwards. That maximum value, max, is on our axis of symmetry because your vertex will always be on the axis of symmetry. So sub in x equals 12.5 to original equation. So there's a 0% chance I'm doing this without a calculator. 0.12 x squared plus 3x. Oh, sorry, I was going to write 3x, but x is 12.5. And so you're going to put it in your calculator and definitely get, oh yeah, I could have got that for sure, 18.75 as being the value of your maximum. So we'll just work from this now instead of, no, let's go back. It's so colorful now. So our maximum is at 12.5 and 18.75. And our domain and range, again, looking at the graph, so it has a maximum. Our domain, you can see we're getting pretty repetitive here until we get into word questions, word equations. Then we'll start to have some restrictions. So our domain is x is an element of the real number system. Our range is y needs to be less than or equal to our value there from our vertex. So it needs to be less than or equal to 18.75. Y is an element of the real number system. I can hear my voice is getting kind of scratchy because this is actually now the 6th math lesson of the day because I taught 2 in class. I did 2 recordings for the 30s, and I'm now on the 2nd recording for you guys. So my voice is tired of math. All right, so that's the function summary for that one. So, written much neater. Maybe we'll just kind of peek through this. So this is kind of similar to what we had on that last page. It says complete the following table of values. Sorry, just let me scroll up. So you see, I wish I could, no, it doesn't let me write on here. This equation is what we're going to have below here. So 8x squared minus 10x minus 1, you see, is this question 2, 8x squared minus 10x minus 1. So previously we said it wasn't easily factorable, so you could make yourself a little table of values for that. So it's giving me what my y values could be. So we're going to, or sorry, what my x values would be. So we have x equals 0, x equals 0.25, x equals 0.5, and so on and so forth. And so what you would need to do to solve for the y values is just substitute in these values for x into the original function and get your corresponding y value. This is really similar to the other question, so I'm not going to bop over to my smart file. But you could choose, we could choose any of those pairs that have the same y values. We could choose the y value of -1, because we have 2 points for that. We could choose the y value of -3, because we have 2 corresponding x values for that. Or we could choose the y value of -4, which is what I did there. So I looked at halfway between the 2 x values that have a corresponding y value of -4. So 0.5 plus 0.75 divided by 2 gets us our axis of symmetry that I have drawn on there in light blue of x equals 0.625. So that's our axis of symmetry. Again, our vertex. This is annoying. Our vertex will be on the axis of symmetry. So in order to figure out our vertex, which is going to be a minimum, we're going to substitute in that value of the axis of symmetry of 0.625. And when you would solve for it, you would get a value of -4.125, which gives us the coordinates of our vertex combined with that axis of symmetry. So that's kind of the same idea as what we did with this one. I'm just trying to see where we go from here. So technology, graphing calculator. Well, maybe I'll just pop into this. Oh, I don't even know what I have on this one. Nope. So what might be some of the challenges to determining the x-intercepts or making a table of values for that guy? So y is equal to -4.9x squared plus 15x plus 1. It does not factor, so we can't do factoring by decomposition. That's not going to get us anywhere. And they're also just kind of ugly numbers. They're not nice round numbers that work nicely. So you end up needing to round your values and it doesn't work out so nice. So what I'm trying to say here is use your calculator. Even if they are nice round values, use your calculator to graph out your function. And then if you have to do it all algebraically, whether it's through a table of values, whether it's by factoring, you can kind of reverse engineer all of the steps. Oh, now it's letting me highlight all of the steps over here. Oh, just for a second. The steps over by my yellow swoosh there. You can reverse engineer it once you have the graph from your calculator. So use your calculator. That's why I gave you that green sheet that has, oh, here it says, see sheet for calculator steps from Casio versus TI calculator. So again, how you find your x-intercepts, how you find your y-intercepts, how you find the vertex. Your calculator will not give you the axis of symmetry at any point. So you need to know how to calculate that. Again, the halfway point between any two y value or any two x values that have the same y coordinate, but you actually could figure out your axis of symmetry pretty easily because it's going to be the x value of your vertex as well. So just some little tips and tricks about how you can use your calculator to do most of the work for you. But again, on a test, you're not going to have that green sheet, so you need to know how to work your calculator. I might recommend going back to some of these and just putting it in your calculator and verifying that this function summary is correct, that our x-intercepts, that you can get to the same ones, that you can get to the y-intercept, that you can see where your axis of symmetry and your vertex are. So that's that. You've got some textbook questions. Before I do this, let's scroll up to the textbook questions. I like that this has like details about what to do for me. So the textbook, if you didn't do page 324, yeah, well, let me highlight. If you didn't do page 324, you'll probably want to do that. And if not, into page 333. So again, thinking about the algebraic process behind it, but also using your calculator to support you. So take care, guys. Bye.